fact, here we are going to talk about training problems. So what can happen during training that can make training unstable? First, let me introduce this idea of long-term dependencies. So it basically means that sometimes, in order to make one prediction, like let's say the Y capital T that you see here on the right, I need information that comes from far away in the sequence. Like let's say in order to make this prediction, I need information coming from X0. And let's say that this sequence is very long, maybe 100 elements. So this is called long-term dependencies because I need to capture this dependency in order to make the correct prediction. And let's see what can go wrong. So here you have a simplified view of what we saw before. In particular, I'm just focusing on when we backpropagate and on that long chain of multiplication that you saw in the example when we were computing the gradient. In particular, you see that the number of elements in this multiplication is the number of elements in my sequence. And that's because I have to go from every ht to the previous ht minus 1. And I have to do that until I arrive to the first one, h0 here. So we said that this sequence can be very long, let's say 100. So we have these 100 elements that we are multiplying. And unfortunately, if we go back to the equation that govern the RNN, and we compute the derivative, so I will not go into details, and actually I didn't even compute this part of the derivative. I just want to show that if I compute the derivative of one internal state with respect to the previous one, there is this W here that is multiplying, well, this part here that I didn't solve, because it's not so important for this intuition. So you see that if I multiply many times this internal state with respect to the previous one, and so on, so these gradients, if I multiply many times, let's say 100 times, I end up multiplying 100 times by W. And actually, this is a problem, because it turns out that there are two cases. Our gradient can either explode or it can vanish. And we will now see at these two cases, and we will try to find a solution to the problem. So we will start with the exploding case. So here, this is a very simplified example where I'm considering W, which is this matrix with the parameter, as just one scalar. And this is just to really see what happens from an intuition point of view when I multiply again and again by the same matrix. Well, in this case, the scalar. And you see that if I have many elements in my sequence, I multiply by W, let's say capital T times. So basically, I'm multiplying by W to the power of capital T. And let's say that in this case, W is 10. So this number will be very, very big because, for example, I can have 100 elements in my sequence. So you see that the gradient is going to explode, and I can overflow. So the backpropagation would not work. There is actually a very easy solution to this. I can just put a limit on my gradient. I say, if the gradient is becoming bigger than a certain threshold, I rescale it. So I want the gradient to be as much, in the worst case, as big as the threshold. And we can do that with this code here, where basically you see I take a generic gradient G, I compute the norm. If it's bigger than the threshold, I rescale it. And the way I rescale it is just I take my gradient G, I divide by the norm of G itself, so now the norm is 1, and I multiply by the threshold. So now the norm is threshold. So that's how I can solve this problem, and it actually works, and is a very easy solution. The opposite problem, vanishing gradient. So here we have, in this case, W is 0, 1. So the same intuition of before applies, and at the end, I'm multiplying my gradient for this number that is 0, 1 to the power of 100, for example. So this goes to 0. So my gradient is going to 0 now. So let's see if we can solve this. And actually, we cannot. We cannot solve this problem. This architecture will not work well with sequences that are very, very long because of this vanishing gradient effect. And the reason is that given that the gradient goes to 0, the architecture will be very, very slow to learn, or most probably not learning at all, in particular for long-term dependencies. So when I need my information to flow for for many steps in the sequence. And to solve these problems, we need to introduce new architectures, which is what we will do in the next slides.